Bright Duty. Every student matters.
Hi dear students, my name is Amit Ajmani and today we'll continue the work and energy chapter in physics. Now till now we have studied about the work. What is work done, how work is done, right, and what are the various things the work is related with. Today we'll be taking up the second part of this particular chapter, that is energy. Now we talk about energy. I don't have energy to do this particular work. Boss, all my energy is exhausted. I need some energy. We have already talked in the starting of this chapter. Why do we eat food? That is basically to get this energy, right? And now, why do we need this energy? Because we have to perform work. We have to do various activities through which we should be able to do all whatever we intend to do. So for all those things we require energy. Now from where do we get this energy? If we talk about the animals and the human beings, we get the energy from the food we eat. And from where does that energy in food come from? So there must be certain sources of energy, right? Now, the biggest source of energy on earth is the sun. This sun is directly or indirectly the source or the cause of many forms of energy. How come? For example, this sun gives us the solar energy that we know. That is the first direct form of energy that we get, right? Second thing, because of this solar energy, the plants are able to do photosynthesis and they are able to convert this solar energy into chemical energy of food, right? So the energy in plants, that is also because of what? Because of the sun. Now when we eat those plants, we derive that chemical energy from them, which is stored in our body in the form of muscular energy, with which we perform all our activities. So we can say that all the three forms of energy, solar energy, chemical energy, muscular energy, the main source is the sun, right? The wind energy and the water energy are also indirectly due to sun. We'll discuss it later, but important thing, the first source of energy and the biggest source of energy is the sun. Apart from the sun, we may get energy from other sources also, like the nuclei of atoms, like the interior of the earth. From the inside of the earth we get geothermal energy. You will study about it later. And the energy from the tides that occur in the seas and oceans. So these are the various forms of energy, right? Now this energy, what we are talking about is, since we have seen there are various sources, so there are various types of energy, right? Now what are the various types of energy we have to discuss in this particular chapter. Now we see the impact and the applications of energy everywhere around us. A few example, if we relate from our day-to-day life, that is, we see that a fast moving cricket ball hits a stationary wicket, and when it hits it, the wicket is thrown away. How come? The work is done by the ball, it has thrown the wicket away. How come? We assume that the ball must have got some energy in it. When we raise a hammer and that raised hammer falls on a nail placed on a piece of wood, it drives the nail into the wood. The nail was stationary initially, right? But when the hammer falls on it, the nail moves inside. How come? That means there must have been some form of energy in the hammer which drove the nail into that particular surface or the wood plank. At times we have seen children winding up a toy, that toy car or toy helicopter or any kind of toy, and then when they leave the winding key, the toy starts moving in the front direction. Why is it so? Once again, somewhere, somehow, we are applying energy. When a balloon is filled with air and we press it, we notice a change in its shape. and as long as we press it gently, it comes back to its original shape when the force is withdrawn, right. So all these examples show a few things. What? Number one, that there is work being done. Why? Because some application of force is there and there is some distance moved by the objects. Second important thing, whenever work is done, there must be some kind of energy involved into doing that work. Now, what are those types of energy that we'll be studying one by one? But one thing is quite obvious and quite clear from this discussion, that whenever we do some work, we require energy, or in other terms, I can also relate that I can do work only with the amount of energy I have. For example, if there is the car or the vehicles, they require fuels, right, for their movement. When there is no fuel, no petrol, no diesel, then the energy providers are not there and we cannot move the car. Similarly, when we don't eat anything for 10 days, our body will not have energy to perform activities. So, we can relate somewhere somehow that energy is related to work, or work is only done when there is some form of energy, right. So, what exactly is energy? Let us now try to understand and define it in terms of science. We can relate that whenever an object is having an capability to do some work, then that object is called to have energy. So, in conclusion, energy is the capability or the ability of a body to do some work. Only if we have energy, then we will be able to do some work, otherwise we won't be able to do it. Got it? So, the object which does some work loses some energy in doing that work, and the object on which the work is done gains energy, right. For example, all these examples that we took, when we just hammered a nail, we did the work by raising the hammer, we applied our muscular energy in raising the hammer. The nail was initially in the stationary position. The energy that we applied in raising the hammer, that was stored somewhere somehow in the hammer, which we transferred to the nail, and after gaining that energy, that nail went into the wood. So, whenever an object does some work, it loses energy, and that energy is transferred to the other object, and when the other object gains energy, then it does some work on its own. Got it? So, this is the basic fundamental of energy. Let us define energy once again. It is the ability of a body to do some work, and since energy is related to work, therefore the SI, or the Standard International Unit of Energy, is same as that of the SI unit of work, that is joule, and this is represented by capital J, as we have seen in the case of work done, right. So, joule is the SI unit of energy as it was of work done, and whatever type of energy we will be talking about, all of those will have the same SI unit, that is joule. Another thing, we also have studied that there are certain bigger joules, bigger units. We also have studied that there are certain bigger units, that is kilojoule and megajoule, that we have studied previously. 1 kilojoule or 1 kJ is equal to 10 to the power 3 joules or 1000 joules, and 1 megajoule is equal to, written as 1 mj, is equal to 10 to the power 6 joules. These are the bigger units, you must know. Got it? Now, there are numerous types of energy, students, right. We named a few. We named solar energy, nuclear energy, tidal energy, geothermal energy, then kinetic energy, potential energy, mechanical energy, heat energy, water energy, wind energy, right. So many types of energy. In this chapter, you will be studying about two types only, right. The next types of energy you will be studying in higher classes. So, let us focus on those two types of energy.